What is input impedance in amplifier design? Imagine trying to listen to music through a tiny straw. The smaller the opening, the harder it is for the sound to pass through. In electronics, something similar happens with signals entering an amplifier. The measure of how much an amplifier resists the flow of electrical current into its input is called input impedance. It is expressed in ohms, which is the unit for resistance. This resistance includes both resistive parts, like simple resistors, and reactive parts, like capacitors and inductors that store energy temporarily. In simple terms, input impedance tells us how much the amplifier pushes back against the incoming signal. If the input impedance is very high, the amplifier doesn't draw much current from the source. If it is low, the amplifier pulls more current, which can affect the signal. This is important because it influences how well the signal source and the amplifier work together. In analog electronics and amplifier design, having a high input impedance is usually better. It means the amplifier won't load on the source device, like a sensor or a microphone. When the amplifier loads the source, it can reduce the voltage of the signal, making it weaker or distorted. By choosing an amplifier with high input impedance, you help keep the signal strong and true to the original. The internal parts of the amplifier determine its input impedance. For example, in a transistor amplifier, the input impedance depends on factors like the transistor's base resistance, the current gain, and the emitter current. Transistor stages can have input impedances in the thousands of ohms, called kiloohms. Some designs, especially those using metal oxide semiconductor field effect transistors, can reach very high input impedances, even in the millions or billions of ohms. Operational amplifiers, or op-amps, are common in electronics. A non-inverting op-amp has an extremely high input impedance because it draws almost no current at the input. An inverting op-amp's input impedance depends mainly on the resistor connected to its input terminal. Choosing the right input impedance is key in many applications. For example, in audio equipment, high input impedance prevents the amplifier from affecting the sound quality. In sensors, high input impedance ensures weak signals are captured accurately without being loaded down. In summary, input impedance is a measure of how much an amplifier resists current flow into its input. It affects how well the amplifier works with different sources and how accurately it can amplify signals. Designing amplifiers with suitable input impedance helps maintain signal quality and ensures the circuit performs as intended.